Okay, say this. Example 7. A coconut of mass 600 falls from a height 30. What is the speed of the coconut before it lands on the ground? So this here, mass is 600 grams. Then it falls from a height 30. Then they ask you, it will drop, and then over here before it lands, what is the speed? This is a conservation of energy question. I would appreciate some assistance from you. Need some assistance.
Distance times time. Distance times time.
Distance times time. Why do you want a distance times time?
Speed is distance time. Distance over time.
Speed is distance over time. Throughout my what 1 hour 30 minutes, did I mention about this formula?
No.
No. What other formulas did I use?
Half mp squared.
Yeah, so that means my question would involve half mv squared and conservation of energy. That means they say total energy is constant. So to find out the answer for this, first you have to figure out what energy is being converted to what other energy.
PE converted to KE.
Yeah, so PE is converted to KE. So PE is converted to KE. Okay, so where is the PE?
PE at the height of 30 meters.
Okay, then all this PE will come down and becomes KE. So can I say PE is the same as KE?
Yeah.
Then how? What should I do next?
mg
Equals to
600 divided by 1000.
we must do this. This formula is this. So this one divided by 1000. So its mass is 0.6 kg.
0.6.
Then
0.6 30 square.
30 square, huh? 0.6 G is 10 times H is 30 equals to half times 0.6 times B squared. What next?
$180 equals to half times 0.6 times B squared.
180 equals to half times 0.6 times B squared.
B squared equals to 180 over half times 0.6.
600.
600 then 600 square root square root of 600. 24.4.
49, so it's 5. Yep, like that.
Yeah.
Next one. Now we have a huge one. You have to dissect the question, sort out all the information that's given to you, then sort out the story, and then figure out. Super long. Feel free to try, then we'll discuss it.
312.5.
312.5. First answer. How do you get the answer? A ball of mass 40 grams is fired from source horizontal at speed of 125. I'm a very visual person that I need to draw. So the ball, okay, V is 125. Then mass is 40 grams. Then I need to convert to 1000. 0.04 kg. Then it collides with a horizontal stationary mass x. So you have this x. Then this is mass is 500 grams equals to 0.5 kilograms. Then it's stuck to it right now. And then move together with the horizontal speed of 10 meter per second after the collision. Then they both swing upwards. Talk so much. Hey, okay, they both swing upwards to a height of how much? H. Then it comes to a stop. What is the KE of the ball before it hits X? So what was your working?
mv squared.
So you did half times
Then half times 0.04 times 125 squared.
yeah. That's true. Okay, so your answer is correct. Okay. Part B. Haven't tried. Well done.
27.
1, 3, 7. What is the key of the ball and object X after they collide and collide and stuck together? So total mass is
0.54.
0.54. So KE will be half mv squared equals to half times 0.54 times 10 squared.
27.
27. Yes. Last one.
Fifty-seven point nine.
57.9. How do you get your answer?
312.
Use the kinetic energy in part B and the fact that air resistance is negligible. This one means no energy is lost to the surrounding. If that happens, that means it goes up by a certain height. That means the KE will become PE. So 27 will be equals to mass GH. Mass is 0.54 times 10 times H.
What?
27 divided by 0.54 times 10. 5 meters. Okay, we will run through this exercise. Then the rest, right, if we didn't finish, will be left as work for you to do. We will start from the first one.
Energy is defined as the ability to do work.
Okay, that's my annotated thing. Define as the ability to do work. This is quite simple. Name the SI unit for energy.
Sure.
This one is long.
Energy cannot be created or destroyed. Energy can only be transformed from one form to another.
Okay, energy cannot be created and destroyed. Can only be transformed from one form to another. Anymore?
Total energy during the transformation is constant.
Question 2.
mgh equals to half mv squared.
Mm-hmm.
Zero 0.6 bracket 10 bracket 6.
6. Look at what?
6.
6 meters from the ground. Okay.
Equals to half 0 0.6
Times E.
v squared.
Okay, so our situation is like this. You have a ball, then the ball is on top here, ground is here. So 20 meters. Then calculate it, so it drops. Then drop until here, which is 6 meters from the ground. Then they ask you what is the speed here.
36 equals to half times 0 0.6.
36, sorry.
36 equals to half times 0 0.6.
36 is half times 0.6. Yeah. So what happens is it
Then E
loses.
squared equals to 36 over 0.6 times half.
We're trying to do this from here. Are you still continuing from here?
Yeah.
No, I'm pondering because what happened is whatever energy that is GPE, that when it falls, it will lose GPE. The loss in the GPE will be gain in KE. So if you put 0.6 times 10 times 6 right here, what you are finding is the GPE at this point. At this point, you are not counting how much energy that is lost and how much becomes KE. Right? You know what I'm saying? Because energy GPE will be transformed to kinetic energy. So when it falls right through that height, it will lose that amount of GPE. So it fell by 14 meters. So when it falls by 14 meters, the loss in, that's not this. Okay, so that means the PE here is MGH, that means is 0.6 times 10 times 20. So we get a certain number. 120 joules here. When it fall down, right, fall until here, right, the PE is 0.6 times 10 times 6, which is what you told me, which is 0.6 times 10 times 6, 36. So because it fell 14 meters, right, the loss in PE is 120 minus 36 joules. So it lost 84 joules. So the 84 joules of GPE that is lost becomes KE. Can I say that? Yeah. So loss in PE equals to gain in KE. So that means 84 is half times mass times V squared. So V squared is 280. V is 16.8 meter per second. You look through again and you let me know whether I should re-explain this.